Projectiles, inclined plane, type 3, horizontal landing. So this question is 2007. So we're told that a plane is inclined at an angle of 45 degrees to the horizontal. And we have to be really careful here because it then says a particle is projected up the plane with an initial speed u at an angle theta to the horizontal. And of course the horizontal was in bold, which was really trying to stress to you that normally our angle of projection is with respect to the inclined plane, but this time it's with respect to the horizontal. And we're also told that the particle is moving horizontally when it strikes the plane. And then we're going to try and prove and show that tan theta is equal to 2. So like in the last question on vertical landing, we're not going to get caught up in how are we going to get tan theta equals 2, more with the information given to us and following our normal paths of working out times of flights, okay? So let's look at a diagram representing what's happening here in this question based on the information given to us. So we have the plane is inclined at an angle of 45 degrees, and then we have the particle is projected into the air such that when it lands horizontally. Now we have to be careful, as I said, because the angle is theta with respect to the horizontal. So in other words, all of that angle is theta, which makes this angle here then theta minus 45 degrees. So let's just undo that. So we have theta minus 45 degrees. Okay. Now it can be a bit messy if you're going to keep writing out theta minus 45 the whole way through the question. So you might choose to just call it angle alpha. And if you do, then please make sure that at the end you put back in for alpha, because otherwise you won't be able to get out tan theta equals 2. Or you can start from the start and subbing in theta minus 45 the whole way down. I'm going to choose to call it alpha and sub in at the very, very end. So as I said, that's your decision what you do. Now, when landing horizontally, we have to note that if it's horizontal to the ground, well, we have then alternate angles from geometry. So in other words, we have this. So we have our transversal cutting two parallel lines, so therefore they must be equal. So therefore we can say our landing angle must equal 45 degrees. So if we're using that information on our landing angle, well, our tan of our landing angle is minus Vy over Vx. And I showed you that in the last video when we were doing vertical landing. I was just reminding you on how and what happens when the particle is landing. So that's going to be key for us in this question. So we're going to have to use that at some point because we know the landing angle is 45 degrees and therefore we can get tan of the landing angle is equal to minus Vy over Vx. Now we also know that on landing, as normal, if it's landing on the plane, that Sy will also equal 0. Okay. So let's just make a note of our two angles here on the side. So I'm saying alpha is going to be equal to theta minus 45 degrees. And beta is equal to 45 degrees. So therefore, if I'm getting sine beta or cos beta, that's going to be 1 over root 2. So as normal, we're going to start by making out a table. So again, you're going to press pause on the video. And you're going to complete the table for U, A, V, S and T in the X and the Y direction, remembering to resolve your gravity because we have gravity in both the X and the Y direction. Okay, so again we have U cos alpha in the X direction and U sine alpha in the Y direction. Or if you're choosing to write it in terms of theta minus 45, then you'll have U cos theta minus 45, U sine theta minus 45. And then you'll proceed to continue on with that the whole way through your question. As I said, I'm going to star that, and at the end, I'm going to sub back in just to make it a little bit neater for my question. So I have to remember that though. That's really important because otherwise I won't finish the question properly, okay? So A in the x direction then is minus g sine beta, but sine 45 is going to be 1 over root 2, so that's minus g over root 2 and minus g over root 2, because that's minus g cos beta in the y direction. Okay, so then we have v is equal to u plus at. So therefore v in the x direction is u, so u cos alpha minus g root 2t, and v in the y direction is u sine alpha minus gt over root 2, and then s is equal to ut plus a half at squared. So if we say s in the x direction is u cos alpha t minus gt squared over 2 root 2, and then s in the y direction is u sine alpha t minus gt squared over 2 root 2, and t for time is just going to be t. Okay, so again, when we're looking at landing, we're going to have to somehow get out that tan theta is equal to 2. So again, as in the previous example for vertical landing, I'm going to look at working out my time of flight with the pieces of information that I know, and that's my tan of my landing angle, and that s of y equals 0, and then I'm going to equate my 2 times of flight. So you can, of course, work out your time of flight and then sub that into your tan of your landing angle. That doesn't matter, you'll still get the same answer out, okay? So either method will work. So we're going to start with, on landing, sy is equal to 0. So we know that sy, we said, if we go back, was u sine alpha t minus gt squared over 2 root 2. So if I let that equal to 0, and I multiply across by my lowest common denominator there, which is 2 root 2 u sine alpha t minus gt squared, and I factorize out t as being my highest common factor. And they both multiply to give me 0, which means one must equal 0 or both must equal 0. And getting t on its own, then I end up with 2 root 2 sine alpha over g. So again, the displacement above the plane is 0 at the start, and the second time s of y is equal to 0 is at the end. In other words, this is my time of flight, which I'm going to call equation 1. So the next thing I'm looking at is on landing. My landing angle equals 45 degrees because it lands horizontal. And therefore my tan of my landing angle is equal to minus Vy over Vx. So I generally would say in class, do you prefer to work out Vy and Vx separately and then sub in, or do you want to do it all in one go? So again, that's up to you. You might want to work out Vy first and Vx second and then sub it in. Or you might want to sub in your time of flight at this point as well. As I said, I'm going to get t on its own, and then I'm going to equate the 2 times of flights. So I'm going to sub everything in here in one go, just to make the video a little bit shorter for you, okay? So tan 45 will be my landing angle. And then I have minus Vy. So again, if I go back to my table, Vy was u sine alpha minus gt root over root 2. So we have u sine alpha minus, and I'll just go back again. So u sine alpha minus gt over root 2. Okay, and then that's over Vx. So again, if I go back to my table, Vx is u cos alpha plus, minus gt over root 2. Okay, so again, brackets in both of those. Now we love when we get tan 45, because tan 45 is just 1. And that gives me minus u sine alpha plus gt over root 2. And that's all over u cos alpha minus gt over root 2. So I'm going to multiply across there, which gives me u cos alpha minus gt over root 2 is equal to mu minus u sine alpha plus gt over root 2. Okay, so we're going to try and get t on its own here. So we want to bring all the t's to one side. So therefore, and I'll multiply across by root 2 as well there. Okay, so we have root 2u cos alpha minus gt is equal to minus root 2u sine alpha plus gt. So that's going to give me 2gt is equal to root 2u cos alpha plus root 2u sine alpha. Okay, so if I get t on its own, I can see I have root 2u over 2g, and I'm just going to take out the root 2u there as being common. So inside the brackets then I have sine alpha and cos alpha. And this is my time of flight, which is equation 2. Okay, so both of these represent my time of flight. So I'm now going to equate both of these. So I'm going to equate 1 and 2. Because they both represent the same thing. So I have 2 root 2 u sine alpha over g is equal to root 2 u over 2g cos alpha plus sine alpha. So again, just going back, so that's our second equation, and that was our first equation. Oh, and I just see there, I'm missing a u in that, my apologies. And that u is not underneath the square root sign, so let me just see, can I make that a bit neater? So that's, oh shit, sorry. Undo, redo. So that's 2 root 2 u. Okay, that's better. Sorry, it's lucky I went back. Okay, so if I have equated those, I can see, great, root 2 is gone, u is gone, and g is gone. And then if I multiply both sides across there by the 2, that leaves me with 4 sine alpha is equal to sine alpha and cos alpha, which means then that I have 3 sine alpha equals cos alpha. And if I divide both sides across by 3 cos alpha, well, that gives me 3 sine alpha over 3 cos alpha is equal to cos alpha over 3 cos alpha. So 3 is gone, cos alpha is gone, and sine over cos is tan. So we have tan alpha equals a third. Now, just to be careful, you're not finished, because if we go back to the start here, we want to show that tan theta is equal to 2. So it is at this point now that I go, oh yeah, hang on a second, alpha actually isn't in the question. Alpha is theta minus 45. And again, it's just made it a little bit neater all the way up until this point. So we say, but alpha equals theta minus 45 degrees. and therefore this is going to become tan theta minus 45 degrees equals 1/3. So we now need to get tan theta on its own. And what you should spot is in trig, I always tell you to write A and B over the angles. And therefore you can spot very easily then that that's tan A minus B, which again, if we go to our maths tables, page 14 and 15, we end up with tan A minus tan B all over 1 plus tan A tan B. Hence I love trig so much because we use it all the time, okay? And therefore if I sub in here, what we end up with then is tan A, which is theta, minus tan B, which is tan 45, all over 1 plus tan A, so tan theta, times tan 45. And again, they've been really nice to you that year in the Leaving Cert because, of course, tan 45 is 1. And therefore that gives us tan theta minus 1 over 1 plus tan theta is equal to 1/3. And now if I cross multiply, I get 3 times tan theta minus 1. So 3 tan theta minus 3 is equal to 1 times 1 plus tan theta. And look at that. Lovely stuff. We have 3 tan theta minus tan theta is 2 tan theta. And 3 plus 1 is 4. And yay, tan theta equals 2. Done. Okay, so you can see why I kept theta minus 45 till the very end, because it just solves so many issues that can often happen at the start of the question. So let's see, where were we getting our marks from? So again, the first set of 5 marks was for getting our time of flight. Second set of 5 marks was again for working out your tan of the landing angle. So for your Vx and for your Vy. And getting out your second time of flight is another 5. And then for getting your 2 things equal to each other, we were getting 5 roughly around here, and then 5 for getting it all out fully. Okay.